So let's begin with what is polymer? Polymer is a repetitive unit of a single molecule called monomer. Now if the monomer is getting repeated together forming a long chain molecule called a polymer. Now different type of polymers are there. Addition polymer, condensation polymer. These two are major. Now what is an addition polymer? Like ethylene gets combined, a large number of ethylene molecule gets combined to give you polyethylene or polythene. What is polyethylene and what is polythene? Ethylene polymerized to give polyethylene and ethene gets polymerized to give polythene. That means one is trivial name, other one is IUPAC nomenclature. Ethene is the IUPAC name and ethylene trivial. So this is the molecule, this polymer. It is a combination of small unit. A polymer is a combination of small unit. Normally repeatedly this is getting added up. Now this monomer unit can be one type or multiple type. If only one type of monomer gets combined, we call it homopolymer. And whenever we have different type of monomer units combined together, we call it copolymer. Homopolymer, same monomer unit, copolymer, at least two monomer units. Now, a few number of such monomer unit can form a block, like monomer A combined together, A like that. Now, after that, a few number of B monomer. There is another block. So block A, block B, block A, block B. This type of polymer, if there, is called block polymer. Okay. Now what is polymerization? Polymerization is the process by which monomer units gets combined to give a long chain molecule. Now the number of monomer units gets combined is called the degree of polymerization. And the property of a polymer depends on how many monomer units are joined together. If less number of monomers joined together, we get comparatively delicate polymer, not that hard. But whenever you have a large number of monomer units joined together, we get it harder. Like you have polythene as example. So low density polythene. There you have small number of monomer units joined. That means degree of polymerization is low. So there we get, it is called LDP. Now if large number is joined together, we get high density polyethylene. So low density polyethylene LDP, high density polyethylene HDP. And what is the application? Small things like tumbler, mug, jar, bucket, these type of things are made of low density polyethylene. High density polyethylene usually laboratory containers, big containers, that is high density polyethylene. You have ultra high density polyethylene, like for example you can have a that sometimes you find white color some tank, reservoir for a water tank or reservoir, which will we obviously will like to have a long durability. Okay, it should have a quite good durability, otherwise nobody will buy it because this is quite costly. Big tank, no? Big tank, so it will be costly. So the quality of material should be very good. So ultra high density type of polymer can be used. Okay.
Ultra high density?
Yes, very high density. Ultra means very. So ultra high density, very high density. Okay. So these three types of polymers are usually that polythene polymers are found very common: low density, high density, and ultra high density. These three types of polymer, they are all that polythene. Now there is another one, polypropylene or polypropene. Polypropene polymer, maybe you have seen that tables made of plastic table, red color, that is there in the canteen. Tables people are using, no? They are usually polypropylene. Okay. Now,
why is it not made by
polythene is actually durability will be less. Polypropylene is durability is more stronger comparatively. Achha, now you have that syntax tank that is blended. It is NB, nitrile butadiene and rubber type, because it is very much inert. Whenever you will make some material which will be used for water storage or something like that for our drinking water, so that polymer should be quite inert. So NBR, nitrile butadiene and rubber polymer, it is a bit flexible, it is tough also, and leaching is less. Leaching means chemical coming out from this polymer into the water. That is called leaching. You know that disposable water bottle, that is Railneed, Bisleri, different type of bottle that we are buying, mineral water bottle. That mineral water bottle, it is clearly mentioned everywhere that it should not be used multiple times. Maybe maximum 1, 2 or 3 times, not more than that. Continuously you should not carry water in that bottle. Why it is so? Because chemical comes out. In that what are the different type of material added as additive? Every polymer has got certain additive. What is added is called additive. This additive is giving some specific property to the polymer. So that is quite inevitable. You have to add it. So these additives comes out with time. Okay, depending on quality. Now water bottle, plastic water bottle that we are buying for storage of water is comparatively better. You can use for 6 months, 8 months, but normally people are using it for 2 years, 3 years. That is not advisable, actually not good. Steel bottle if you use is much better. You can use it for a much longer time. Particularly if you store some hot water into that plastic bottle, it is really dangerous because chemical leaching takes place. Okay, so small tarpaulin cup. I am talking about polymer, so you should know about these polymer problems. Okay, this small cup that is used in the canteen, and if it is plastic made cup, that is very bad for health. It is cancer causing. Okay, it is very delicate also. So when you hold it, you will find it is quite hot. Cannot hold it properly. Okay, that type of polymer is very dangerous. Taking tea into that polymer. This polymer cup is very nowadays you will find paper cup. It is replaced because this cancer problem is established. People know about this. That's why nowadays this plastic cup is replaced by paper cup. But paper cup has got a problem. Paraffin coating is given inside the paper cup. Otherwise, it will soak the solution. Paraffin means wax, moam. Okay, that coating is given into the paper cup. Otherwise, it will soak. The solution will soak the cup, and immediately it will be spoiled. So cannot hold it long time. That's why a paraffin coating is given. But when you put some hot material into that, hot cup of tea or coffee, so it melts and it goes into our stomach, and that is also very dangerous because our stomach, this membrane is very much sensitive, and through this membrane we are exchanging lot of food materials and everything. Okay, food we are sucking from that stomach into our blood vessels. So this, if there is a paraffin coating there into our stomach, how the exchange will go on? Okay, day by day, not in one day, continuously if you do that, then the paraffin coating will be there into our stomach itself. So exchange of material will be very difficult. So it gives trouble. Okay, that is also really bad. So then what is the alternative? Glass or mati. But that is also got a problem. Giardia. If it is not properly burnt, okay, it can contaminate with, it can be contaminated with giardia. You can have a stomach upset problem. Giardia is a sort of dysentery, amoebic dysentery. Pet kharab hoye jabe. Sometimes you don't understand. I have not taken anything bad, but suddenly how I am getting stomach upset problem. It happens, no? These are the small things. That way it happens. Okay. Sometimes your hand is not disinfected. You have got lot of bacteria into your hand. From the hand also your stomach upset problem. Okay. Anyway, that's a different issue. Let's talk about polymer now. So polymerization is the process. It is a polymerization is the process and polymer is the product. By combination of these small unit called monomer unit, you get this polymer. Okay. So now our biopolymer amino acid is getting joining together to give a protein chain. That is also a biopolymer. So we are dependent on polymer. Practically, those who are sitting here, including myself, all are full of polymers. Okay. All the living bodies are full of polymers because protein, keratin, everything is polymer, biopolymer. So we are all polymer, full of polymers. So polymerization, there are two types, major type. One is called step growth and another is called chain growth. Chain growth means repetition is very fast and by itself happening by itself, like ethylene to polyethylene or propylene to polypropylene. Butene to polybutene, butadiene to polybutadiene. So this type of polymerization, these are all called chain growth. And what is the meaning of chain growth? Repetition of the unit happening very fast. And actually, if you consider a double bond, hey, just look at me. So suppose this is a double bond. Here is a carbon, this is carbon, this is carbon. There is a double bond. So when it opens up, you get two hands open. When it breaks, double bond breaks, you get two position open. This is open, this is open. Then third one can join here. That way the polymerization is happening. Double bond is broken and repeatedly the monomer units are getting added again and again and again. You get a long chain. That is called chain growth polymerization. And it is very fast at random. And how does it happen? By radical mechanism. First of all, the radical is formed. Like for example, ROOR, that already you are familiar with. I have already shown you earlier. ROOR. So it is we have used where it is anti-Markovnikov of addition. Yes, the same thing is happening here. It's also radical polymerization. That the same mechanism, radical mechanism. So what is happening? First of all, ROOR is broken into RO dot. That is everyone is happening. Okay. So this RO dot is a radical, so that RO dot can join at one end of the double bonded compound and the other hand is opening now. Okay. And when the other hand is opened, then it can take up another molecule of double bonded compound, that is alkene. Another molecule of alkene, same alkene, another molecule. Then another one. That way it goes on. So first of all the initiation by the radical formation, after that propagation, continuously getting added up, forming a long chain, and at the end there is termination. Again the same steps, all the three steps. Okay, initiation, propagation, termination, and at the end, termination can happen by different ways. One, it can accept another radical. Secondly, two radicals can join together. Suppose R dot joining with another R dot, you are getting RR. That is also another possibility. And the third possibility is called disproportionation. One R molecule is getting accepting one hydrogen from another molecule. So one is becoming double bonded one, means alkene. Other one is becoming alkane. So one alkane and one alkene simultaneously form. That is called disproportionation reaction. This is also possibility for termination. So this is called chain growth polymerization. Repetition of the unit by radical mechanism which is high energy. And what is the solvent here? Non-polar solvent. Either no solvent or non-polar solvent. Sometimes there can be no solvent. Gaseous state. Gas is joining together in presence of certain catalyst. Okay, so that is possible.
Why we use non-polar solvent?
Non-polar solvent is better because radical favors non-polar. Radical mechanism we are doing. So non-polar solvent only suitable for the radical polymerization because solvent has no role here. As solvent has no role, so that the other solvent may retard the reaction because it can create some barricade in the way. Suppose you have someone has no role here in the class. If the people are thus standing here, it will create a barricade between us, isn't it? The same thing. They have no role, so why they will be in this position or the situation? So yes, that's why it is not required. And if there, it should be inert, quite inert. That's a non-polar. Non-polar is usually inert. more inert. Polar is more active. Polar always tries to participate in something. So non-polar is not like that. So non-polar, if there will be no problem. And non-polar has another role. Sometimes what you have, if you have some solvent, suppose non-polar solvent, then the material may be dissolved in that, and they can come in closer proximity. Usually gas is quite away from each other, molecules are not close. But if you allow the gas to dissolve, they will come closer. So that is a possibility that molecules are coming closer and joining together faster because they are closer. Okay, so what this solvent is doing? Allow them to come together. That is also help. Okay, so that's why non-polar solvent is favored for this chain growth polymerization. Another one, condensation polymerization. That always happens in polar solvent. Condensation polymerization will be there into the polar solvent. What is condensation? Suppose you have an acid molecule and one amine molecule. One acid and one amine. What happens? Reaction between the two, you get amide. Amine is RNH2 and RCOOH is the acid. So reaction happens and you are getting RCONHR. That is called amide. Amide. Now, just imagine in that compound you have a chain, and at the end of both the chain you have two COOH groups. One COOH here, one COOH here. Okay. Another molecule you are taking where NH2 group is there at both the ends. NH2 here, NH2 here. Now this COOH and NH2 can join together, and this COOH and NH2 can join together. That way, one after another, they can join repeatedly. It's called polyamide. First I talked about amide. Now, if the situation occurs that the molecules that we are taking are bivalent, both the ends we have one active functional group, like COOH, NH2, NH2. Now after that you are joining, allow them to join. So after what you get, this polyamide. Example, nylon 6,6. Nylon 6,6 is an example. What are the monomer units? Adipic acid and hexamethylene diamine. These two specific monomer unit. One is called adipic acid. What is the adipic acid? CO2H, CH2, 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 C2, CO2H. So how many carbon? CO2H, CH2, 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 CO2H. How many carbon? 6 carbon. CH2 4 number. Okay, follow me. CO2H, CH2, 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 CO2H. Total 6. So at both the ends you have got CO2H. That is called adipic acid. Another molecule we take NH2, CH2, 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 NH2. 6 carbon. Again. Both the ends you have NH2 and other one, both the ends you have got CO2H. Allow them to join and make a polymer. You get, that is also a polyamide, but in this case that particular specific one, polyamide is a general term. Now specifically what you get is called nylon 6,6. And why 6,6? Because both the units are having 6 carbon. That's why 6:6 is written, and when you read it, we call it 6,6. Okay, nylon 6:6 written like that. না ডট ডট থেকে কোলন। আচ্ছা, তো কমা হতে পারে, নো প্রবলেম, মিনিং সেম। আচ্ছা, কন্ডেনসেশন or step growth polymerization happens like this way. One COOH and another NH2 joining together. What will come out? No, amide will be the main product. What is the side product comes out? Water. One molecule of water coming out. So this type of reaction where two things are getting added together followed by a release of a small molecule called condensation. Release of a small molecule here, in this case water, it is called condensation. Now the problem of this reaction, I will talk about the problem of this reaction. When you follow the condensation, water will be accumulated, which is coming out from the reaction. So continuously water will be accumulated, and you know the problem of accumulation. When sufficient quantity of water is accumulated, then the back reaction may take place because you are having all the reactant together. So back reaction can take place. That's why the reaction will reach an equilibrium.
be back?
Reversible, back reaction. Reaction always goes forward. What do you think?
No, sir.
It goes backwards also. So backward reaction will take place. That way I am calling back reaction. Backward reaction. So backward reaction also taking place, and you are getting some equilibrium. So that will not allow the reaction to proceed further. Maybe you are getting 60% productivity, not never 100%. That is the problem of this condensation polymerization.
No, suffering it also.
It will stop. And you have to know there is a way. If you apply a bit higher temperature, the water will be evaporated out. So product is one of the product you will remove from the media. So automatically reaction will proceed further. Okay, this type of technique you have to use, and you are getting much better reaction. Instead of 60%, you will get 80%, 90% productivity. Never 100%, but 80%, 90%, 95% productivity can be achieved. Okay, but higher temperature, you have to consider all the facts. If you go for a higher temperature, what will happen? You have to apply certain cost, which is bad for the company. Okay, so you cannot. You have to always take some in between optimum condition. Okay, because if you want to get 90% productivity, maybe time taken is too long. But if you are getting 80% productivity, time is taking much lesser. So 80% you should be happy with the 80%, not to the 90%. Okay, so that is called optimum condition. What is economical, whatever is taking less time, okay, that is also another factor. Always 100% productivity is not the factor. You have to consider all these factors together. I am talking about actual manufacturing. There all these things you have to take care of. Now, functionality of monomer. Some are monofunctional. Like here, OH group, monofunctional, because only one functional group. This is also monofunctional, only one functional group. So what you are getting? This. But in this type of reaction, we are not getting any polymer. You will never get any polymer. This type of monofunctional molecule, if you take and allow them to react, you will never get a polymer. Because this is what you are getting, a single molecule, not polymer. Okay? So this concept of functionality we are discussing now. Functionality means number of functional group into a molecule. If you have a more number of functional group, there is a obvious possibility of polymer formation. But if you have only monofunctional molecule, then there is no possibility of any polymer. Okay? That from the example you can clearly understand. Okay. So this reaction, if you do this type of reaction, you are getting functionality 1. But if you have this functionality 2, like OH both sides, this can undergo polymerization. You get polymer. But if you have only monofunction like acetic acid, you will never get a polymer. Okay, it's a common, very very simple idea. Because you don't have both hands, na? Only one hand on one side, one valency. So automatically that will be filled up and closed. Okay, so this COOH is doing certain reaction and it is closed. You are giving PCl5 into acetic acid, you are getting CCCOCl, closed. You are not getting polymer. But whenever bivalent molecules are there, you have a COOH both ends, CO2 is both the ends, NH2 both the ends, it can undergo polymerization. So this is bifunctional, trifunctional. Whenever monofunctional, it cannot undergo polymerization. But whenever bifunctional or polyfunctional, they can undergo polymerization. Why do you need to understand about polymer? Because we are using it. We have a lot of application. Everywhere polymer is needed, and day by day polymer was becoming more popular. But nowadays another problem has come. That is the longevity of the polymer. Polymer is very long lasting. Okay, durability is good. But after it is torn or broken, what you will do with that? You can go for recycling. Achha, but recycling, do you know what is the inherent problem into recycling? First time virgin polymer, what quality you are getting? Second time with a recycled polymer, quality will become much lower, not that good. Strength of polymer will reduce a lot. Okay, if you reuse a polymer, strength is not be good. Or recycle the polymer, strength will be bad. Like you have got a broken tumbler, একটা গামলা ভেঙে গেছে. Okay, what you will do? Normally you sell it to that bhangar wala. What they are doing? Taking into some factory, and after that it is breaking and then molding, casting, and making another new material, new article. Okay, so from this use polymer, but the quality of that material will be much lower. can bend, it will break. It will not be that hard. Why? Because second time heat when you are giving, the chains will become fragmented. Long chains will become fragmented. छोटा छोटा fragmented মানে छोटा छोटा टुकड़ा में divide हो जाए. That is called fragmentation. কি হলো? এখন কি? 10 লেট ছিল কোন 10? ব্ল্যাক রোজি লেট হচ্ছে?
স্যার 2 ঘন্টা লেট করেছে।
আচ্ছা।
আবার একটা মহিলা চেঞ্জ করে দিয়েছিল।
Okay, so okay, could you understand if you have a polymer, you are heating the polymer, molding the polymer once again, the polymeric chain, long chain becoming shorter. That I am telling fragmentation. Long chain becoming shorter, and already I told you long chain is stronger, short chains are weaker. So if it is becoming fragmented, it will become weaker. Okay, and that is quite unavoidable. It will happen. It will happen. Whenever you heat, some of the polymer chains will be broken down, smaller fragments.
So is there any reason?
That
Be
when,
the strong of the long chain?
no, whenever you are heating, long chain strong. Okay, bonding. It can have more bonded, na? Long chain will have a bonding, good amount of bonding. Broken chains cannot have that much of bonding. More bonding, more strength. Less bonding, less strength. Very simple idea. Acha, now, if you just keep some certain polymer material into open air over a long time, suppose in a rooftop, ছাদে একটা প্লাস্টিকের টুকরো ফেলে রেখেছো, or maybe nylon দড়ি, দেখেছো এটা nylon দড়ি, okay, after 6 months, if it is used for 6 months, after that what happens? 6 months, 8 months, 1 year, what happens? फटाफट हो जाए, কেন? फ्रैगमेंटेशन. प्रैक्टिकल एग्जांपल देख लो, होता है ना. अच्छा, now why does it happen? Daytime sunlight exposure, getting heated up, and night time cold, heat cold, stress. Due to lot of stress, it is broken. And rainfall, acidic rainfall. Slowly it is making weaker. Na? And another thing, oxygen there in the atmosphere, this oxygen is sometimes oxidizing some parts of the polymer, and in the chain, it is this fragment chain, oxygen is getting added up from the air. Oxygen getting added up from the air into the fragmented chains. That way it is making very weak. Okay, polyamides are soluble into alkali. So if you have a nylon rope put into certain acid, it may not be destroyed, but if you put into some alkali, it will be torn or broken into fragments, small parts, piece, and then ultimately it will melt, completely dissolve in a which. Okay, so polyamide is very strong, nylon dori very strong, but if you put into some alkali, it is gone. If you put into acid, no problem. Put into alkali hydrolyzes this material, that's the reason. Acid also can, but lesser, not that fast, but alkali can dissolve it very fast. Our hair, if put into acid, nothing will happen. Put into alkali, it dissolves. Okay, this is a practical idea I have done, tested. Okay, so different type of these compounds, they are having different functionality. That is just a chart to make you understand that there are a lot of different type of functionalities. Some polymers are straight chain, some are branched, highly branched. Those who are straight chain, they are usually very strong. Straight chains are strong because fiber. I'm talking about fibers. Fibers means fiber. So fiber is strong, na? Then can, because whenever this long chain are binding together, one chain is maybe weak, 2 chains, 10 chains, 20 chains, 100 chains, it will become stronger and stronger. And when you keep them together like a bunch, it becomes so tough you cannot tear it apart. It becomes very tough and strong. Fiber property. You have seen polybags, small polybags you are carrying, sometimes called carry bag, taking 5 kg of potato. So that's that packet I am talking about. The transparent packet that is giving a shopkeeper is giving us. So when you carry it, sometimes what happens, the handle becomes stretched. Handle is becoming stretched, and it becomes so tough then. You check yourself that when it is stretched, after that it is becoming tougher. Why? Because it is becoming fibrous nature. Becoming fiber. Fiber means all are aligned in the same line. Like this. All are aligned in the same line. It will be obviously tough. একটা কাঠিকে ভাঙা যায় 10টা কাঠি একসঙ্গে ভাঙা যায় ছোটবেলায় পড়েছেন unity is strength that is happening here unity is strength that is happening in this case so practical life real life you can if you can join with your study will be more interesting always try to do that whatever you are learning in the practical life and whatever you are studying if you can combine them together it will be much more interesting. So here, this one is a monomer, but is a bifunctional monomer. This monomer is called OH and OH both are there. So this is and three are there. Sorry, 1, 2, 3. It is glycerol, glycerol, same thing. Acha, how do you get glycerin? Do you know what is the major source of glycerin? Any organic fatty fat. Vegetable fat, oil, you do the saponification. You get two things. Soap and glycerin. That is the major source of glycerin. That is the way we are getting glycerin source. Take any oil and fat, vegetable oil and fat. It may be animal fat also. If you do the saponification, you get soap one hand and the glycerin is another. Okay, these two things are formed. This process is called saponification. Hydrolysis of fat or edible oil with sodium hydroxide, caustic soda or caustic potash. You get sodium soap or potassium soap. Stearic acid, palmitic acid, oleic acid, they are sodium potassium salts. Regarding hardness I discussed that one. Okay, so this is glycerol and this is what? This is called phthalic anhydride. Now this glycerol and phthalic anhydride, so you are getting it is written phthalic anhydride, it is glycerol. So we are getting a polymer chain. This is a chain. And what is this meaning of the curly arrow? It is still there. What you could not draw. You cannot draw up to infinity. So you have drawn up to something and then giving some curly arrow, that this curly line that indicates there is still something left that you could not draw. So that means it is a chain. This is not ended here. So here is also another chain. It is not ended here. And this is giving good amount of branching also. Not straight chain always. Normally when you give example, you draw straight chains for simplicity. But branching is quite inevitable. Along with straight chain, branch chain also will be there. So functionality of monomer, linear chain polymer. Functionality of more than 2. When the functionality is more than 2, you are getting branched one. So this is branched one because functionality is more than 2. That's why you are getting branched. Chain growth polymerization characteristics. These things are usually strong. Chain growth, hard material. Polythene is hard, no? Polythene, polypropylene, polybutadiene, these are all hard materials. That is the property. This chain growth polymer, because chains are usually long chain, it also happens very fast. It is not step by step. Rather, both the open hand is joining with another two molecules together, so the whole process becoming very fast. And what is the mechanism? Radical. And for step growth, what is the mechanism? Ionic. Condensation. And condensation, whenever condensation happens, it is molecular level. One molecule, second molecule is coming, joining, and then another small molecule going out. So molecules are usually bulky, heavy, they are slow. Big molecules, they are bulky, heavy, slow. So this condensation polymerization occurs for a bulky molecules, that is quite slow. And this addition polymerization of chain molecule, they are doing this very fast because molecule units are very small. CH2 double bond CH2, so small. So they will join tremendous fast. But these larger molecules, because of their bulk, their movement is also slow. So rate is also slow. Molecule itself moving slowly. So joining rate will be slow. and you are getting this polymerization also in a slow rate. Not only that, it is never ended. You get 60% polymerization, 70% polymerization. But that does not mean always we go for chain growth. That is also not there, because we need, according to our requirement, we will make it. Na? Okay. So now, depending on the molecule, it will go either chain growth mechanism or step growth mechanism. That we cannot help. Like these polyamides, they will always go in a step growth. You cannot make it a chain growth. It is a step growth, because reaction is condensation reaction.
Sir, ওখানে যে লাস্টের আগের পয়েন্টটা ছিল যে চেইনস আর নট অ্যাক্টিভ আফটার টার্মিনেশন ওকে
Close, na? Bond ho gaya. Termination means ended, reaction ended. After that it is no more active. Reaction stopped.
active means
Active means-
react anymore.
No further reaction, because already is closed. Until till it is open, it can react. If it is closed completely, how it will react?
As you say that it till infinity.
No, not infinity. Means if you draw up to 20, 30, 40, you cannot draw. Na? That is our infinity for us. For we can draw how many? Maximum 2-3 molecule. That repetition we can draw. Not more than that. So that's why there are two customs. We can make a bracket and put in.
Yes.
That is one custom. Or another one is just dot. That means it is there. Both the end. It is not closed yet. It is open. Okay, long chain. So lot of differences actually. This chain growth and step growth, chain growth, lot of differences. For chain growth, you need some initiator, radical. Some initiator will be needed. And for step growth, you need some acid or alkali. That will initiate the reaction. Instead of initiator means normally radical generator. But in case of step growth, no radical generator. We will need some acid or alkali or enzyme. Acid or alkali or enzyme will be required. Okay? Into our body, whatever this polymerization reaction is going on, it is step growth. It is not chain growth. Into the body, there cannot be any radical mechanism. Always there will be ionic mechanism. Why? Because our body has got a lot of water, no? So aqueous media. Depending on media, it is happening. So into our body, you have media, and our this amino acids are all the units that will capable of forming some polymer, but in a step growth mechanism. Okay, because polycondensation is going on. That is happening by molecule getting added one after another, just like a fabrication. One joint, then second joint, then third joint. Very good that artwork type, just joining one by one, forming a chain. Free radical polymerization, initiation, propagation and termination. So this is the initiation. So bond breaks here. Not always ROR. Yes, in this case you can AR, OO, AR, COO, AR. This is air, aryl group. R, whenever we write R means alkyl group. Here, if it is this ring compound, we call it aryl. So this is one aryl group, this is one aryl group, and you have a OO linkage, which is peroxo linkage. So whenever peroxo linkage there, it becomes very delicate. This bond breaks quite easily. Why? Because there is a lone pair over here and there is a bond pair, lone pair bond pair repulsion, and lone pair repulsion makes it very vulnerable to attack. So this position breaks and you are getting free radicals. They are very much active. Ready to react, that is called active. Unreactive is not ready to react, so it is unreactive. So initiator, free radicals are generated. What are free radicals? Reactive atom or group. Like Cl dot is a free radical, CH3 dot is also a free radical. Sometimes a group of atoms or a single atom can act as a free radical. List of free radical initiator. These are the initiator chemical that you need to use when you do the reaction. Which reaction? Chain growth reaction. Chain growth reaction means addition polymerization, and step growth reaction means condensation polymerization. These two things are very common. These are free radicals form. Lot of free radicals available. Okay. Big list. Now propagation. The free radical form joining with a double bonded compound, opening the chain in the other side. Now there is a dot here. So plus another molecule of this will join. And that way it will continue further and further. But how much it will continue? See, there is a lot of competition among the molecules. Lot of competition among the molecules. Whoever getting whatever available nearby, it is accepting. जिसके सामने जो आ रहा है वो accept कर रहा है. So someone can get 20 molecules one after another joined together. Another side, less number of molecules available, so it has got 15. And another one, it has got a large number of molecules are available nearby, so it has got 25. It happens like that way. So random way, you get 15, 20, 25. Hey, whatever you are copying, you can do it later. Close it now. So when you are in the class, you must be attentive. So small molecules joining together, 15 number, 20 number, 30 number. So random way it is formed into a particular polymer. Suppose polyethylene itself, the chains are never same, never the same. Different sizes of chains are there. Small chain, medium chain, long chains. Okay, so that's why monomer has got a particular molecular weight. Polymer does not. Polymer has a lot of possible molecular weights. If you have a long chain, you have a large molecular weight. You have a small chain, it will have a smaller molecular weight. Then what? How can you derive the molecular weight of a polymer? Okay, we'll discuss later. So just giving some rough idea. So one is called number average, and there is called weight average. Average you will have to take. Why? Because chains are always random. Small, medium, long. Very long. Very short, very long. Medium. So different type of polymeric chains are there. That is called degree of polymerization. Degree of polymerization 10, 20, 15, 20, 30 different sizes are there. On an average, you have to get the polymer molecular weight. That is called number average and weight average. These two average molecular weights will be calculated. Okay. Now modes of propagation. How to join with other molecules? One after another. But how? Head to tail. एक का head, दूसरे का tail. हो सकता है. Head to head. Tail to head and tail to tail. These are the possibilities. This end is joining with this end. Or this end is joining with this end. Or this end is joining with this end. These are the possibilities. Suppose this is head, this is tail. Head to head joining. Possible. Head to tail joining. There. Head to tail joining. And tail to tail joining. These are the three possibilities. And tail to head and head to tail actually is becoming the same. Then termination. Two radicals join. This one radical, this is another radical joining together, giving it is terminated. Ended. Terminated means ended. No further reaction. This is stable. Quite stable product has formed already. So no further reaction. This is called termination. This is called combination. This method is called combination. This is disproportionation. Already told you that one molecule will be donating one hydrogen to the other molecule. So one is becoming double bonded, the other one is becoming alkane. Alkane and alkene type. This is the alkane type, this is the alkene type. That's called disproportionation. And what is the meaning of disproportionation? Oxidation and reduction, both the reaction happening in the same molecule. From same molecule. One is getting oxidized, the other one is getting reduced. So donating hydrogen is what? Oxidation. And those getting the hydrogen is getting reduced. So one is getting reduced, the other one is getting oxidized. It is happening together, called disproportionation. See, redox reaction means always oxidation and reduction both are happening together. That's fine. But same molecule, one getting oxidized, other getting reduced. Specific, isn't it? That is called disproportionation. Always one molecule is oxidized, another molecule is reduced. That is natural. But if it is same molecule, that is called disproportionation. Same molecule, one of them is getting oxidized, other one is getting reduced. That is called disproportionation. And it happens by donation of hydrogen. One is donating and accepted by the other. Who is donating is oxidized and who is accepting is reduced. Chain transfer. This is chain transfer. This is a chain and from here the one hydrogen is getting joined. So here there is a dot. This position is not satisfied. This carbon has got 3 bonds. You see, this particular carbon has got 3 bonds. Now one hydrogen is taken from this another chain. So that's why it's called chain transfer. From one chain, another chain is getting transferred and getting terminated. Telomerization. See telomerization with this example. A solvent of high chain transfer ability. Solvent of high chain transfer ability. What is the solvent here? CF3Br is the solvent. It is transferring one bromine to the chain, polymer chain. It is transferring one bromine atom to the polymer chain. High transferring ability. Because CF3Br, the bromine is prone to be going out quite easily. Why? Asymmetric molecule. Carbon, fluorine, but one bromine, big one. Not very good situation. If it can be removed, it will be quite happy. So it is donating. Chain transfer is happening. I think time is up. Okay.